Hi, today we are going to present our group project titled Implementing Project Based on the Business Analytic Lifecycle. This is the introduction of our team members. Next, let's move on to Task 1, Data Extraction and Exploratory Data Analysis. The purpose of this analysis is to examine the impact of marketing campaigns on household buying behavior. Specifically, we aim to understand how different campaigns influence customer engagement and coupon redemption. The objective of this analysis are to identify the most effective marketing campaigns, to discover patterns in product purchase and coupon usage, to support data-driven decision-making for future marketing strategies. For this analysis, we use the complete journey datasets, which contain the detailed information. Here is the dataset list that we use. In terms of our analysis approach, we integrate multiple datasets to establish relationship between campaigns, coupons, and product purchase. We also analyze household demographic data and transaction behavior to understand customer response. For tools, we use Tableau for data visualization and exploratory data analysis. Now, let's move on to our findings on the most effective marketing campaigns. To evaluate campaign performance, we calculate campaign effectiveness, which is the ratio of household that redeem coupons to household that receive the campaign. First, this graph shows the campaign reach the household received. It illustrates how many households were targeted by each campaign, giving us an overview of campaign reach. Next, Graph 2 presents the household redeem per campaign, which shows the number of households that actually redeem the coupons. This helps us to compare customer engagement across different campaigns. The most important visualization is the third graph, campaign effectiveness. This graph combines both reach and redemption to show how effective each campaign truly was. From the result, campaign ID 18 achieved the highest effectiveness at 18.89%, meaning nearly 1 in 5 households who received this campaign redeemed a coupon. This indicates that campaign 18 was the strongest performing campaign in terms of customer response. Next, we analyze product purchase pattern using transaction and products dataset to understand which item were purchased most and least frequently. Graph 1 shows the most frequently purchased product. It highlights the top 10 products by purchase frequency. From this graph, fluid milk white only record the highest number of purchases, with 1898 purchases, indicating that it is a highly popular and frequently demanded product among households. Graph 2 presents the least frequently purchased product by product type. While this graph shows the many products recorded zero purchase, the large number of such items makes the result difficult to interpret clearly. Therefore, the most important insight comes from Graph 3, least frequently purchased product by product category. This graph provides a clearer overview and shows that home finishing had the lowest purchase frequency with only one record purchase. This suggests that certain product categories have very low demand and may require improved marketing strategies or inventory review. Next, we analyze buyer behavior based on coupon redemption across different age and income groups. This heat map shows that most demographic segments have high coupon redemption, as indicated by the dark shading. This suggests that coupon promotions are broadly effective and appeal to households regardless of age or income. Based on our analysis, we propose several recommendations to improve future marketing campaigns. First, companies should focus on high-performing campaigns by analyzing successful campaign features such as product type, coupon value, and targeting strategy. Effective approaches can be identified and replicated in future campaigns. Second, it is important to target products with high purchase frequency. Promoting high-demand products can help maximize customer response. Additionally, bundling popular products with low-demand items can encourage cross-selling and increase overall sales. Third, attention should be given to low purchase products and category, such as target promotion, improved incentive, or a review of inventory decision may help improve performance. Finally, business should leverage the effectiveness of coupon across demographic. For example, continue using coupon as a core marketing tool. At the same time, introducing personalized or segment offers could further increase customer engagement.
Now, let us dive into multidimensional modeling. The objective is to design and implement a data warehouse model that supports multi-dimensional analysis of retail transaction data. We apply data warehousing concepts such as SAS schema design and the ETL process to enable 1, 2, and multi-dimensional analysis. Python was used for data processing and Tableau was used for visualization. The data used includes detailed information on products, promotions, campaigns, transaction, and time attribute. From this dataset, we focus on transactional sales data, specifically sales amount and sales quantity, which provide the basis for analytical reporting and trend analysis. A SAS schema was designed to support efficient analytical queries. The model consists of a central sales fact table connected to 4 dimension tables, which are product, time, promotion, and transaction. The fact table stores sales amount and sales quantity, while the dimension table provides descriptive context for slicing and aggregating the data. The ETL process was implemented using Python. First, the raw CSV files were extracted using pandas. During transformation, surrogate keys were generated, time attributes such as month and time of day were derived, and data cleaning was performed. Finally, the transformed data was loaded into Tableau, where relationships were defined based on the star schema. For one-dimensional analysis, we analyze sales performance using a single dimension. Sales amount by month was used to identify overall sales trends and seasonal patterns, while sales amount by department shows how revenue is distributed across different product departments, highlighting which departments contribute most to total sales. Two-dimensional analysis combines two dimensions to enable comparative insights. Sales amount by month and product category shows how different categories perform over time, while sales amount by month and department further analyzes how departmental sales change across months, providing deeper insight than single-dimension summaries. Finally, for multi-dimensional analysis, we combine three dimensions, which are month, department, and time of day. This analysis reveals distinct purchasing patterns across departments at different times of the day, such as morning, afternoon, and night. In conclusion, the star schema design successfully supports one-dimensional, two-dimensional, and multi-dimensional analysis, enabling flexible and meaningful business intelligence reporting.
Alright, for the task 3, we focus on customer churn predictions using predictive analytics. Alright, so what is customer churn? Customer churn is the customer who stops making purchase over the time. This is a critical issue because churn leads to a direct revenue loss, increase the cost of acquiring new customer, and also reduce the overall customer lifetime value. Therefore, predicting the churn early is very important for the sustaining business performance. From a business perspective, it is to identify the customers with a high risk of churn and support the targeted retention campaigns. From an analytics perspective, the goal is to build a churn predictions model and identify the key behavioral factors that influence the churn. The expected outcomes will be improve the customer retentions, build a more efficient marketing budget allocations, and better decision making. This analysis will use the complete journey dataset. The transactions datasets provide the key behavioral indicators as shown in this slide. The promotion datasets contains the information about the product promotions. It helps us to understand the customer exposure to the marketing campaigns. For data preparations, the transactions and promotions were merged using the product ID, store ID, and week, and the data was aggregated to the household level. From this, we create the behavioral features including recency, frequency, and monetary value. The churn was defined as the customer who did not make any purchase in the last 6 weeks, and the final datasets was then used in the RapidMiner to develop the churn predictions models.
And my name is YONG, and my metric number is 217176. And for the customer churn modeling part, I'm using this list of the algorithm in the RapidMiner, that is logistic regression, decision tree, and random forest. And this is the process flow I drag and drop in the RapidMiner. And this one is the evaluation of the model. So why we choose the logistic regression? So by comparing the accuracy, precision, recall, classification error, AUC, measure, sensitivity, and specificity, we can notice that the logistic regression is the best model. While random forest is a highly powerful example method, logistic regression was identified as the top performing model for the dataset with an accuracy of 98.2%. And this is attributed to the strong linear correlation between customer recency and churn behavior. The model efficiency captured the primary churn indicator, which extended the time since last purchase without the overfitting risk associated with more complex algorithm. And the first reason is it has the superior predictive performance. As we can see, it actually achieved 98.2% of the accuracy, which shared with the random forest, while the decision tree lags at 95.2%, and it maintains a low 1.8% classification error. And for the precision and specificity, it reached a perfect 100% in both precision and specificity. This means that the model has zero false positive, which is critical if the cost of a false alarm is high. And for recall and sensitivity, it achieved 97.9%, which matching the random forest and beating the decision tree. And for F measurer and AUC, it boosts the highest F measures, which is 98.9%, and a perfect AUC of 1, indicating that a flawless ability to distinguish between the classes. And the second reason is the exceptional computational efficiency. While the decision tree is slightly faster at training, the logistic regression is the fastest at scoring, which is the prediction, and is nearly 4 times faster than the random forest at processing new data. In a real application where you need instant prediction, this speed is a massive advantage. And for the last reason is the stability and reliability. The standard deviation column shows how much the model performance vary during the testing. Likely cross-validation for the logistic regression shows very low variance. And for the decision tree, it's much more shaky with a variance of 1.5%. And this suggests that the logistic regression is a more robust and less likely to overfit the training data, which has the lower variance with 0.6% for the accuracy, than the decision tree, which has a 1.5%. The final selected model, logistic regression, will be deployed as the core component of the company's customer retention system. Because logistic regression provides a clear probability score for churn, It allows the organization to transition from reactive marketing to a proactive early warning system. We're going to use the weekly scoring process, which is the rapid minor scoring process will be automated to run every Sunday using the latest transaction data to calculate the churn probabilities for all active households. And for threshold management, households with a predicted churn probability higher than 0.7, which is 70%, will be automatically flagged for immediate intervention. And for CRM connectivity, this high-risk identifier will feed directly into the company's customer relationship management CRM dashboard for the marketing team to action. And for the strategy for retention campaigns, deployment is only effective if the model's prediction trigger the right action. Using an insight from the EDA, the following deployment actions are recommended, which is the automated coupon triggering. High-risk customer will receive the digital coupon model after the campaign 18, which demonstrated the highest redemption effectiveness at 18.89%. And we have the personalized bundling. Since the fluid milk white only is the most frequently purchased item, the deployment system will offer standard as anchor in promotion to ensure all households return to the store. And for the recency mitigation, as recency was the strongest predictor in our logistic regression, the system will trigger a "we miss you" notification as soon as the customer exceeds their average purchase interval. And for last one is the continuous model monitoring and maintenance. To institutionalize the business analytics as a core competency, the deployment phase includes a feedback loop. First one is the performance tracking. The data analytic team will conduct a monthly review of the model's accuracy and record to ensure the logistic regression remain calibrated as the customer shopping habit evolved. And the last one is the A/B testing. The company will deploy the test and control groups to measure the actual revenue saved by the model-driven retention campaign compared to the standard mass marketing.
For Task 4, we present recommendation for the CEO based on insight from our exploratory analysis, data warehouse modeling, and trend prediction using complete journey dataset. First, we recommend prioritizing high-performing campaign structures. Campaign ID 18 achieved the highest coupon redemption rate at 89%, showing that effective campaign design can significantly improve engagement and marketing ROI. Secondly, we suggest leveraging high-demand products for growth. Fluid milk white only was the most frequently purchased product, and using it as a promotion anchor or bundling it with lower performing items can increase cross-selling and basket size. Next recommendation is optimize underperforming product categories. Underperforming product categories such as home furnishing should be reviewed. Targeted promotion, improved placement, or pricing adjustment can be applied before considering product removal. We also suggest operationalize customer churn prediction. The churn prediction model developed in Task 3 allows early identification of high-risk customers. This enables timely retention action like personalized coupons or loyalty rewards to reduce customer churn. Finally, we recommend institutionalizing business analytics across the organization by embedding analytics into daily decision-making and investing in the right tool. Besides that, skilled professionals ensure continuous insight generation and long-term competitive advantage. Overall, these recommendations show how business analytics support better strategic and operational decisions. That's all from us. Thank you.